So let's talk about some real world use cases. You actually, before we started recording,
Mhm,
you were telling me about how with crime, that is
mhm,
often
mhm,
a really good use case of
mhm.
graphs. It can give you insights that you couldn't get with any other kind of approach.
Yeah, and I would say finding bad behavior, whether we're talking about money laundering, that's a really typical one, fraud rings, but also like international criminal organizations as well, even things like supply chain crime as well, which is actually quite significant. The reason why graphs are so good about finding aberrant or bad behavior is that if you think about how somebody trying to hide their tracks, they don't. If you have activity going on, usually there's multiple touch points in criminal behavior. So it's not like somebody walks through the door and advertises that they are doing something criminally bad. They're actually trying to act and behave in a way that is, air quotes, normal to other customers or patients or what have you. And what you really need to do is be able to understand, connect the dots between multiple behavior and touch points over time. And which is, if you imagine what that would look like, that looks like breadcrumbs. And you're having, you can almost, I can see the graph in my head. You have these dots of touch points and links between them, relationships, and you breadcrumb through that to see aberrant behavior or an aberrant or an anti pattern or a pattern that shouldn't be there. And then the other thing is those things usually happen over time. So you can't just snapshot in and look for a bad actor. You have to be able to look at that over time and look at how the behavior develops over time. And the other thing is, really bad behavior is rarely a one person or one entity point in time thing. It usually has multiple different collaborators. And so, again, you need to be able to see the relationships between those collaborators and their behavior and their addresses and. And so you can imagine that gets into lots of dots and links between them, and that's hard to look at as rows and tables. If you look at that as rows and tables, you're just not going to see a pattern. And graphs have that unique ability to pull that important pattern out so that we can see that.
You explained that really well. That was really easy to understand and gripping, frankly. What else? What other kinds of use cases are out there in addition to crime?
Well, so recommendations is a classic one as well. So, for example, like for Netflix, if they're recommending a movie to me, they may that I haven't seen, but it's a movie that has a director in it that I like, or a director in it that I maybe like, but the other people who like that director recommend this other movie. And so you can build a similarity based on behavior and what people like and don't like. So that's classic recommendations. You see that all over the place. The other thing you can do things like optimizing networks of things like supply chain. We all saw supply chains break down during COVID, totally broke down. And part of that was because most of the way we were looking at supply chains was looking at the past. And this is a classic machine learning mistake, is that you do correlations, you make predictions based on what you've seen in the past. But if you don't understand your network, your customers, your supply chains, your partners very well, and you're just predicting based on what you've seen in the past, when there is an event that shifts the underlying reality, you are going to fall down. You're going to make wrong predictions. And so you need to be able to understand the patterns and understand how things shifting in the supply chain may shift your predictions. And you can do things like finding the optimal route. So graphs historically, and I think World War II, they started being used for supply chain, looking at supply chain during actually troop supply chains during World War II. And if you have something that blows up, or you have a railroad that can no longer be used, you need to look at another route. And so graphs are really common for route planning. Uber uses graphs, things like that. Like, how do you find the best route? It's all through different points. But if you, in a supply chain standpoint, if you have a warehouse that goes out of commission or a port that you can no longer dock in, what's your next best route? And that is a common graph used in supply chains, is the top K, or the next, the top routes. that are optimized for these complex shipping and delivery routes. So that's another really common one would be supply chain. But quite frankly, anytime you have connected data, you can use graphs to help you optimize.